In previous part, we talked about what Docker is and why should we use it. If you haven't watched that video, I would recommend to watch it because today I will show you how Docker actually works under the hood. We'll keep it simple. We'll go, but we will go one level deeper. You will see that Docker is not a magic. It's mostly Linux commands put together in a smart way. Hello everyone, I am Anjali Shukla. Welcome to PG Cloud Security. Let's get started. In Linux, namespace is like giving a private space to all the processes. Think of it like living in a shared building. All people are inside same building, but each flat has its own door, own furniture. People in one flat cannot see what is inside other flat directly. So Docker uses the same concept for containers. When Docker starts a container, it gives processes inside the container their own PIDs, network interface, mount points. So let's take a real example. Let's say there is a user that has UID 1000 and has name www-data inside the container. Whereas on host, this user has a name user, but same UID 1000. Why is it so? That UID is same, but username is different. That is because of /etc/passwd file present in different environment. One is at the host and other is inside the container. And if we look at the processes level, you might have seen fewer processes in the container as compared to host. At host, all the processes are visible, whereas inside the container, we have very limited process. So here we have a lab where we will see how this, like how it happens, where we have a different number of processes inside a container and an host. And we'll use an example of watch command. So when we actually starts a container, let's say I'm running a Docker run hello world. So what will happen at the backend? So first of all, system D starts the Linux system and Docker daemon. This Docker D is a Docker daemon. It receives that Docker run request and talks to the container D that manages containers and images, a complete lifecycle of a container. Now, container D uses another tool, which is runc. And runc is actually responsible to start or to spin a container. So runc is kind of a worker that say, okay, now I will set up a namespace and then start the process inside that isolated environment. So it is a tool that implements OCI runtime specifications, and we can use the strace command to see or to check the namespace or all the system calls happening inside that process. We'll just have to take a PID and run the strace command. So here I will discuss two important system call. One is unshare, another is clone. So unshare is used to isolate parts of process environment, and it uses clone new PID to create an isolated namespace process ID. And it has a PID 1 because it is the first process that it starts inside the container. It might have a different PID at the host level. So first of all, so when the runc, like when runc receives a request, it starts or it calls the unshare system call, and then unshare uses a clone to create a new PID namespace using the clone new PID. And that gets a PID 1 inside the container. We have other calls as well that is called by clone system call that are clone new ns new net for the network and the mount points. If I want to check the PIDs of the process, then we can use a read link -f /proc followed by the process ID and /ns. There I will get all the process IDs for that namespace. So similarly, we have a clone new user call for the user namespace. So you must have seen that inside a container, we have a root user, but that is different from the root user present on a host. So let's quickly start our lab for the day. So first of all, we will change the permission of docker.sock. This is for the lab purpose. So we are changing the permission. Otherwise, in production, we will not change the permission of docker.sock. So let me copy it and paste it here. So I've changed the permission. Next, I will run my container with alpine image and sleep command. So name of my container is test in ns. So my container is running in a detached mode. And now I will install the proc ps inside my container, as it is an alpine one. So I'll be using a apk package repository, and then I will run a watch ps aux command in background. Okay, my container is running. Let me just verify with docker ps command. Yes, my container is running. That has name test ns. Next, I will get the PID of this watch command inside my container. So 13 is the PID inside the container for the watch process. So let's see namespaces for our current shell first of all, and then we'll see for this particular process at our host system. So this is a command like proc slash dollar dollar we use to get the namespace IDs of the current shell. So I will use that. So as you can see, I am getting the namespace IDs for the C group, IPC, MNT, Mount, Net. These are the IDs for these namespaces. Okay. Now we'll get the namespace ID of our PID one, that was the process running inside my container. So as you can see, these both have a different IDs. The shell process, like my current shell, has a different IDs, and this process, which is a PID one inside my container, has a different namespace IDs. So what we have done, we are just comparing both the output, and if you'll see that MNT, PID and net, these are in different namespaces and has a different namespace ID inside a container for the process running inside a container and for my current shell. So this is a UTS, and it is ending with 224, and inside my container it is ending with 232. So it's a different IDs. This was it in this video. Further, I will also discuss the Docker namespaces C groups in detail in our next video. So stay tuned and subscribe our channel. Thank you.